Welcome to Note Studio. In the last video, we have learnt about chemical reactions and examples for chemical reactions. Today, let us study about chemical equations. Chemical equations. We can represent chemical reactions in two different ways. The first way is word equation. In word equation, a chemical reaction is expressed in words rather than chemical formulas. So what we'll do, in word equation, we won't use chemical formulas or symbols. Rather, we just write or we just express the reaction using the words. Okay. A word equation shows change of reactants to products through an arrow placed between them. The reactants are written on the left hand side with a plus sign between them. Similarly, products are written on the right hand side with a plus sign between them. The arrowhead points towards the products and shows the direction of the reaction. So let us study these explanations with the help of an example. So this example we have discussed before in activity 1.3. So let us discuss it again. So here we have taken the example like zinc metal, it is reacting with the dilute sulfuric acid, and two different products are formed, zinc sulfate and hydrogen gas. So now this reaction can be written in words. So here this is one long sentence, correct? Very long sentence. This chemical reaction we have expressed in very long sentence. That can be we can make it very short way using just words. Now zinc plus sulfuric acid, which gives zinc sulfate and hydrogen gas. Okay, now let us study about this. Now the same example. Now this is zinc and sulfuric acid. These both are the reactants. These both are the reactants. Okay. And now zinc sulfate and hydrogen gas, these both are the products. Yeah. And always reactants are written in the left hand side. Reactants are written in the left hand side. Products are written on the right hand side. Right hand side. And then these reactants and products are separated by an arrow mark. Okay, now this arrow mark shows the direction of the reaction, and it also shows where the products are formed. See, after the arrow mark, we'll write the products. And you can notice another important thing here. There is a plus sign between the reactants as well as between the products. If we have more than one reactant in the left hand side, we'll separate two reactants. See, this is one reactant, this is the another reactant, correct? So in between we'll use the plus sign. The same way here we got, in this example we got two products. Zinc sulfate is one product, hydrogen gas is the another product. So we are separating these two products using the plus sign between them. I hope you have understood about this. We'll go to the next topic, that is chemical equation. Chemical equation. The shorthand method of representing a chemical reaction in terms of symbols and formulas. See here, we are using the symbols and formulas instead of words. Okay, in word equation, we'll write entire chemical, or we'll represent entire chemical reaction using just words. But here, we are representing that chemical reaction using the symbols and formulas of the different reactants and the products. Okay, now the same above chemical reaction or word equation can be written like this. For zinc, we know the symbol of zinc, that is Zn. Sulfuric acid, H2SO4. These two are the reactants, and you can see the arrow mark, it shows the direction of the chemical reaction. And then both products are formed, zinc sulfate and hydrogen gas. These two are the products, and these are the formulas, right? And this is the symbol of zinc. So like this, we'll use the symbols and formulas to represent a chemical reaction. So instead of writing very long sentences, this makes easy to understand. Next, we'll study about another important concept, balanced and unbalanced chemical equations. Let us study about the easiest one, a balanced chemical equation. So a balanced chemical equation has an equal number of atoms of different elements in the reactants and products. Did you get the point? In the reactant side as well as in the product side, equal number of atoms will be present. Equal. So then we can say that that equation is balanced. Again, we'll take the same example and we'll study about it. So here we have taken the same one. Zinc is reacting with the sulfuric acid, and then zinc sulfate and hydrogen gas is formed. And now you know that this is not a word equation, this is the chemical equation. Why? The reason is we have used symbol as well as formulas to represent this reaction. Now let us count the number of atoms in the reactant side as well as product side. This is the reactant side, these are the product side. Now let us count. Number of zinc atoms. Okay, number of zinc atoms present in the reactant side. Correct? See here, how many zinc atoms? We have written Zn, just Zn. That means one zinc atom is present in the reactant side. How many zinc atom present in the product side? Again, only one, Zn SO4. SO4 is again different atoms, but Zn is only one. Number of hydrogen atoms. In the reactant side, it is H2. H2, that means 2 hydrogen atoms. What about in the product side? Again, you can see the formula H2, that means 2. Right? Equally, it is present. In reactant side, 2 hydrogen atom. Product side, 2 hydrogen atom. Let us count now sulfur atoms. See here, you can see, yes, atoms. Okay, we are not counting any formulas, we are counting the atoms. So now you can see only one S is there, one sulfur atom is present. That's why in the reactant side 1. Now what about in the product side? What you will say? Right, again it is only one sulfur atom, just one. So we have written 1. Number of oxygen atoms. We can see here we have represented 4, O4. That means 4 atoms of oxygen in the reactant side. And what about in the product side? We have mentioned here O4. Again 4 atoms of oxygen is present in the product side. See, equally. Atoms are present in equal number. Do you think, is this a balanced equation? Yes, yes, it is balanced chemical equation because equal number of atoms of different elements is present in reactant side as well as in the product side. I hope that is clear. Now let us go to the second topic, a very interesting topic, unbalanced chemical equation. As the word says, Unbalanced means the equation is not balanced. That means there is no equal number of atoms present in the product as well as in the reactant side. Okay, so let us study using the examples. Example: hydrogen reacts with oxygen to form water, and this is now just one expression of chemical reaction, and now we are writing this using the formulas. H2 plus O2 gives H2O, and here we did not use any plus sign because only one product is formed. Here there are two reactants, that's why in between the reactant we have used plus sign, and you can see the arrow mark. This is the direction of chemical reaction. Now this is the equation. Now let us count the number of hydrogen and oxygen atoms present in this equation. No other atoms, right? Now let us count. In the reactant side, this is the reactant side, how many hydrogen atom is present? 2. Product side, H2, again 2. Number of oxygen atom, O2, we have written O2, that means 2 oxygen atoms are present in the reactant side. Now what about hydrogen atom? You can see just only one oxygen atom. O2, 2 oxygen atom in the reactant side, and in the product side just only one oxygen atom is present. What do you think? Is this equation is balanced? No, right? Here hydrogen is balanced. Okay, in both the sides equal number of hydrogen atom is present, but oxygen atom, no, it is not balanced. Now this type of equations are called as unbalanced equation, and this is also called as skeletal chemical equation. Unbalanced equations are also called as skeletal chemical equation. Now you may think like why we have to balance it, or what is the problem if the chemical equation is unbalanced. But in the previous year or in class 9th we have studied about the law of conservation of mass. What it says, mass can neither be created nor destroyed in a chemical reaction. That means total mass of all the reactants must be equal to the total mass of the products. See, mass of the reactant, total mass of the reactant and mass of the product should be equal. When it will be equal? Equal number of atoms should be present, right? So chemical equations are balanced to satisfy the law of conservation of mass in chemical reactions. So it's very important why we need to balance chemical equations. The reason is to satisfy the law of conservation of mass. According to this, the mass can neither be created nor be destroyed in a chemical reaction. Hence, it's very important to balance a chemical equation. And unbalanced chemical equation is also known as, yes, skeletal chemical equation. In the next video, we'll study about how to balance unbalanced chemical equation using different examples. Thank you.